Live from Earth, it's Space Radio. This is Paul Sutter, and coming up, we're talking about Asteroid Bennu Blues, Peekaboo, I See You, and Missing an Opportunity, if I have time, of course, and taking listener questions about all things in the universe. We record the show every Thursday at 4 p.m. Eastern. Call 888-581-0708 to join the conversation. You can also call that number anytime and leave a voicemail. And in today's Blue Shift, I'll be talking about a story about UFOs. Hello, space fans. Welcome to Space Radio. I'm Paul Sutter, astrophysicist at Ohio State, chief scientist at COSI. For the next half hour, your agent to the stars. I got an exciting show for you today on Space Radio, where we talk about all the beautiful, wonderful, glorious things happening in the universe. This show lives on listener questions. We record every Thursday at 4 p.m. Eastern here in Studio A of WCBE Radio Columbus. Call 888-581-0708 or leave a voicemail anytime. Get those calls in. You can also follow along with our space cadets on the live stream on YouTube and Twitch. Go to spaceradioshow.com. You can join all the wonderful people tuning in live from SLC, from Allentown, from Washington, from Austin, from Belgium, from Orange County, from the UK, from a Welsh village with a rude name, from Rio de Janeiro, from Copenhagen, from Norway, and from Sweden and England. Chiming in at just the last second. Get those questions in. That's spaceradioshow.com for the links. Seriously, folks, I've only prepped 10 minutes of show material tops, so get those questions in. Before I start taking calls, I want to share some cool bits of news I caught recently. What really caught my eye is something that caught the eye of a camera attached to a spacecraft as it undergoes its journey into the solar system. I am talking about NASA's Origins, Spectral Interpretation, Resource Identification, Security, Regolith Explorer, aka osiris-rex. Have a feeling we came up with the name first and then made an acronym from it. This is a spacecraft that was launched almost 2 years ago. I remember osiris-rex launching, and it does not feel like 2 years ago. It feels like just a month ago, but it is headed to a near-Earth asteroid. Now, let that phrase sink in, these two facts. It is headed to an asteroid nicknamed or called Asteroid Bennu. It is classified, are you ready, as a near-Earth asteroid. It took this spacecraft 2 years to reach it. If you are near the Earth, you are still 2 years of travel time away. That by itself demonstrates just how big stuff in space is. So Asteroid Bennu, as asteroids go, isn't that remarkable, which is why we're looking at it. It is representative of a kind of asteroids that have a lot of carbon inside of them. We think that asteroids that are very rich in carbon are leftovers, are relics, are time capsules from the early days of the solar system. They haven't been changed much. They weren't formed recently from later collisions. They were formed early on and they just kind of hung around or floated around, whatever you prefer to do in space. So Asteroid Bennu is rich in carbons. Carbon. Who cares about carbon? Oh yeah! Everybody cares about carbon because we're all made of carbon. All life on Earth requires carbon to build itself. We are walking bags of carbon and water. Carbon is an essential ingredient for life. It's a very friendly element. It likes to make lots of friends and build long, complex chains and structures. And it can do everything from fingernails to fins to flippers to foliage on trees. It's all made of carbon, and Asteroid Bennu has a lot of carbon. I wonder if Asteroid Bennu might provide some clues as to the origins of life here on the Earth. Life needs carbon. There's lots of carbon from the early solar system. Put two and two together. Asteroid Bennu has a few secrets up its sleeve, perhaps. And we're not just going to take pictures of it. We're not just going to measure it and look at it and ooh and ah. The instrument, osiris-rex, has a device on it called the TAGSAM? the tag SAM, the touch and go sample acquisition mechanism, the tag SAM, which is like a big metallic proboscis that's going to reach out and go and take a chunk out of Asteroid Bennu, stick it in a little cylinder, and that cylinder is going to take a few years to come back down to Earth, and it's going to splash down in our oceans or hit the land, and we're going to pick it up, we're going to carry it to our laboratory, and we're going to touch an asteroid. Maybe not touch it, maybe we'll do some other things first, like study it very carefully under laboratory conditions, but then we're totally going to touch it because we want to know what Asteroid Bennu feels like. That is a very important question. That is the latest and greatest when it comes to space, but it's time to have a conversation. You ready for the voicemail, Greg? How you doing, space cadets? By the way, I got a question for you, got a technical question for you. We're running into some noise and interference issues in our setup today. We have no idea why. I can hear it on my headphones, but I think I was able to apply a filter so it doesn't appear on the live stream. Let me know if you hear any noise up or down, yes or no. And keep those questions coming, and thank you so much, Nets and Granziano, for wrangling them and putting them up where I can see them easily. Sounds great on Twitch. Thank you so much, Scott Bragnon. We got thumbs up from Dennison of Earth. I think we're good to go on the live stream. Thank you very much, folks. We tried to test it as much as we can. Yeah, Larry Beckham, it's a backronym. I'm betting that osiris-rex is a backronym. To kick things off, we have the voicemail. Are you ready for the voicemail, Mr. Gregory? Yep. Okay. I'll tell you when to play it. I'm so lost. We've got a voicemail on the line, ready to go. Give it a shot, Greg.
Hi, I'm Terry. I live in Columbus. My question is, what could be a sound wave in outer space? My trusty dictionary gives definitions of sound and acoustic that seem to be earthbound definitions. I'm wondering what it would be to be near a star where there is, of course, no atmosphere. Could you hear the star? Thanks.
Wow, wonderful, wonderful question about the nature of sound and sound waves in space. Can we hear anything in space, even if you get up close? So I want you to play a mental game with me, everyone. We're going to replace the wave sound, or the words sound wave, that phrase, sound wave. We're going to get rid of it. I'm not going to say sound wave anymore, except for that one time where I said I was not going to say it anymore. Instead, I'm going to use the phrase pressure wave. Pressure wave. And I think by switching to this, to a slightly more technical term, we can get a better handle on what's going on up in space. Sound is waves of pressure. If I'm talking to you and I'm flapping my lips and my vocal cords are vibrating around, they are squeezing the air. They are creating differences in pressure in the air. And these differences in pressure will start traveling. They'll start slinking back and forth all around me, filling up the room. So all the air in the room is caught up in these undulating, wiggling waves of pressure. And sometimes these waves of pressure can encounter, say, your eardrums, and they'll start forcing your eardrums to wiggle back and forth, and then your brain interprets that as me talking. So in order to create a pressure wave, you need a fluid. You need something to do the waving. That waving could be the air. That waving could be the water. But you go out into space, space is defined as the stuff between all the interesting bits. There's nothing. You can't hear anything in space because there's nothing there to support pressure waves. There's nothing to wiggle. But this doesn't mean pressure waves can't exist in particular regions in the universe. For example, our sun. Our sun is a giant ball of plasma, hydrogen and helium. It's a thing. It's stuff, right? Stuff can support pressure waves. It can wiggle back and forth. There are sound waves crashing through the sun right now. And in fact, we use these sound waves, these pressure waves, excuse me, I used the word I'm not supposed to use. We use these pressure waves to study the interior contents of our sun. Because if you start monkeying around with what the sun is made of, how thick the various layers are, how hot they are, how much action is going on underneath the surface, you change how these pressure waves move and wiggle throughout the sun. So we can look at the sun and we can see its surface wibbling and wobbling. And we can use that to understand the interior contents of the sun. We call this Astro Seismography. The same way you would use sound waves crashing through the Earth to study the interior of the Earth, you can use sound waves crashing through the sun to study the interior of the sun. It's one of our best ways for figuring out what's going on underneath the surface of the sun. We can also do this on other stars. That's right, we can do Astro Seismography on other stars. And we can go to dense clouds of gas and dust and we can see pressure waves. They may be very weak, they may be very long, but they're there. We can see them undulating and wiggling and waving like flags in a wind. We can even go back to some of the earliest moments of our own universe. When our universe was way younger, our universe was way smaller and way hotter and way denser. At one point, our entire universe itself was a plasma. It was filled edge to edge. There are no edges, but bear with me here for the sake of the illustration. Filled edge to edge with stuff, with a fluid, with a medium, and there were pressure waves crashing around throughout the entire universe, and we can see the imprint of those pressure waves. Even today, the technical term we give for those, lots of jargon here in this segment, but it's lots of fun. The sound waves in the early universe we call baryon acoustic oscillations. Oscillations, wiggles, acoustic, sound waves / pressure waves, and baryons, it's what the universe is made of. So what the universe was made of was wiggling way back when, 13.8 billion years ago, and we can still see evidence of those pressure waves today. So pressure waves are ubiquitous throughout the universe, but the vacuum of space itself prevents these pressure waves from going anywhere interesting. We can shout as loud as we want here on the surface of the Earth, but as you go up and up and up and up to higher and higher altitudes, lower and lower air pressure, those pressure waves are going to peter out because there's nothing left to carry them. Excellent question on the voicemail. I'm Paul Sutter and this is Space Radio. This show is brought to you by you. Visit patreon.com/PMSutter to learn how you can keep this show going, and I will see you after the break. Sound waves in space. Yeah, I know in space no one can hear you scream. But stars scream. Ryan Schmitz. I like that question. Will the James Webb become operational before the universe becomes iron? Yeah, probably not. It's a toss-up. JWST launches, heat death of the universe. I don't know. It's like 50-50. Talk to your bookie in Vegas. Pretty decent odds either way, which I guess is 50-50 odds. Yes, I said sound wave. Sorry. Leopold Roos, good question too. All right, I've got enough for another segment. Thank you so much. Welcome back, everyone. I'm Paul Sutter, and this is Space Radio. We've got some more Space Cadet questions ready to go. Remember, you can join the conversation by calling 888-581-0708 or by calling that number anytime and leaving a voicemail. You can also follow along with the live streams. Go to spaceradioshow.com for the links. There, you can do this either on YouTube or on Twitch. It is free. It is easy. You don't need to download any apps or install any special software. You can just click a link and watch. I won't even make you chat. You can chat if you want. You can type in your little questions and get those questions on the air. But you know what? Just knowing that there's someone out there listening and watching is enough for me. Now, my first Space Cadet question today comes from Ryan Schmitz over on YouTube asking, what is the most exciting thing you would want found in an asteroid sample? You know, going back to this discussion on the Asteroid Bennu and the osiris-rex mission, which is going to collect a sample and send that sample back to the Earth for further study and also lots of touching. What do we like to see? What would we like to see? Are we going to see, I don't know, spores or little microbes or tardigrades hitching a ride? Probably not. We're probably not going to see life hanging out on this carbon-rich asteroid. But there's a chance beyond carbon, we can find the building blocks of life. We could find, say, amino acids or protein structures or organic compounds. This would be very interesting because we're trying to answer an extremely fundamental question about our universe. How did we get life on the Earth when everyone else is dead? What was our special sauce? What was our secret ingredient to go from obviously not alive to obviously alive? What kind of building blocks? What kind of connections? What kind of combination of elements and circumstances led to life and then ever increasingly complex life here on the Earth? Well, maybe if asteroids contain some organic compounds, maybe even proteins or amino acids, some very, very simple stuff. This might be an interesting clue. I don't know exactly what the implications might be, except that it'd be super awesome. Now, also on YouTube, another Space Cadet, Thunderduck, also following up with Asteroid Bennu, asking, where did the carbon in the asteroid come from? And this asteroid, I just kind of stated, I said, oh, there are some asteroids that have a lot of carbon and they're remnants of the old solar system or the early days of the formation of the solar system. And the carbon in an asteroid like Bennu comes from the exact same place that the carbon that make up your bones and skins and fingernails and eyeballs and sweat glands and everything comes from. We were born with it, baby. It was part and parcel of the cloud, the nebula that eventually collapsed to form the solar system. This cloud had a bunch of stuff inside it. It had a lot of hydrogen and helium because the whole universe has a lot of hydrogen and helium. And it also had a sprinkling of other stuff. It had some oxygen. It had some boron. It had some plutonium. It had some carbon. Carbon is very common. So the nebula that became the solar system had a lot of carbon in it already. Some groups of carbon tended to clump together and form these very carbon-rich asteroids. Now, where did the carbon come from in that giant cloud that led to the solar system? Carbon is fused inside of stars like our sun. Right now, our star is turning hydrogen into helium and doing a very good job at it. Thank you very much. In the far future, near the end of its life, it will fuse hydrogen and helium. It will fuse hydrogen into helium, and it will fuse helium into carbon and oxygen. Carbon and oxygen are some of the most common elements in the universe. Far cry from hydrogen and helium. They always get top spots. But after that, carbon and oxygen are very, very common. In fact, oxygen is the number one element in the Earth because carbon dioxide in our air, oxygen itself in the air, and then rocks are silicon dioxide, silicon plus oxygen. There's a lot of oxygen and there's a lot of carbon. Very, very common in our universe because stars make them. And then stars die and become nebula, and the nebula collapse and become new stars, and the circle of life in the galaxy continues. Now, totally switching tracks. Actually, only a slight deviation from that. From Pavel Novicki, also on YouTube, a space cadet, asking, have we ever observed star ignition? Have we ever seen a star turn on? Start doing its thing. A star, by definition, is something that, in at least part of its life cycle, fuses hydrogen into helium. That's our definition of the star. Don't bother arguing with that. No one's going to listen to you. If you want to be a star, then at least at some point in your life, you must fuse hydrogen into helium. So as a cloud of gas and dust is collapsing and condensing and getting hotter and getting denser and doing all sorts of interesting things, at some point it becomes a star. At some point, the critical threshold is reached, and then it's a star. Of course, from the outside, it's not like it changes very much. From the outside, as it's collapsing, as it's forming, it's a ball of really hot hydrogen and helium. And then fusion turns on in the core. And from the outside, it's a ball of really hot hydrogen and helium. Kind of hard to tell the difference. A star that's getting started, that's being kickstarted, that's just on the cusp, is called a T-Tauri star. Because of astronomy reasons, I'm not going to get into the name of why they're called T-Tauri stars. They just are. T-Tauri stars are our name for the stars that are just getting going. The youngest stars, the pre-stars, the stars that are starting to ignite fusion. There might be fits and starts and complaints, like the engine in Greg's car. Someone please get him a new car. He could really use it. And it doesn't quite run as efficiently or as smoothly as it could. And the T-Tauri stars are the stars that are just now getting started into starhood. Stardom. We'll stick with stardom. Now I'm going to totally switch gears. And I'm going to talk about the expansion of the universe. I'm going to talk about galaxies being carried away from us. So we live in an expanding universe. It's a fact. We've known it for 100 years. On average, galaxies are getting pulled farther away from each other. We do have some friends that are going to be lifelong companions with us. For example, there is the Andromeda Galaxy. Andromeda Galaxy is our nearest neighbor. It's a nice, big, mature galaxy. It's our best friend. In about 5 billion years, we will collide with it. We are headlong racing into each other. We will merge starting in about 5 billion years to form one big galaxy called Milkomeda or Andromeda Way. All the names are pretty dumb. But either way, it's going to be a big galaxy. We'll be glued to them to Andromeda forever. There are some other galaxies, smaller galaxies like Triangulum and some satellite galaxies that are also members of what we call the local group. The local group is that group of kids that will remain lifelong friends well into adulthood. The expansion of our universe, the accelerated expansion of the universe, will carry every single other galaxy away from us. Every single one. Fast forward into our future 100 billion years, no other galaxies will be visible. None. Zero. It'll just be us, the local group. Our little pocket, our little corner will be our entire universe. So you think we're lonely now, just wait. We're almost out of time today on Space Radio, but before we go, it's time for the Blue Shift. What do you guys think we should call the merged Milky Way and Andromeda? What do you give it, Greg? Milky Way and Andromeda, the two galaxies are going to merge. What do we call that thing? Greg's got nothing. Go back to reading the paper, Greg. It's hard, isn't it? Maybe I shouldn't be so hard because I make fun of like and Milkomeda and Andromeda Way, but I guess it's kind of hard. It just needs a new name. Like Harvey. No, we don't like Harvey. Harvey's a spoiled name now. We don't use that. Like Jessica. Let's just call it Jessica. That's a nice name, right? If you want to name the merged galaxy, email request at iau.org, email the International Astronomical Union to just call it the merged galaxy, call it Jessica. We can also call it a hot mess. Well, Jessica is kind of a hot mess. You know, she's got to get her life together. Hershey's Galaxy, that's trademarked. All right, let's make this blue shift happen. I'm Paul Sutter, and you're listening to Space Radio, and this is the Blue Shift, my opportunity to get a little bit closer to you. And I want to tell you a little story about UFOs. Not UFOs like unidentified flying objects, but UFO the movie, starring Gillian Anderson, David Strathairn, Ella Purnell, Alex Chance, coming out September 4th on digital platforms. This is a movie that was filmed down in Cincinnati, Ohio. This is a movie that I was very lucky to serve as a science consultant for. And I also appear in one scene. I do appear in one scene with David Strathairn. I had lines. I was legit. I was cast. I was paid union scale. I have my SAG membership, the whole deal. I had just 2 lines where I was being sarcastic, so I didn't have to act at all. And but the lines ended up being cut because the whole scene didn't flow. I was assured it wasn't because of my stellar performance. It was because of the needs of editing the scene. So I'm in there and I'm like shaking my head and smiling and laughing at David Strathairn as he gets more progressively angrier. But I wanted to tell you a story. Gillian Anderson plays a math professor, and her students are the main characters. And of course, a lot of scenes are going to take place in the classroom. And so the movie takes place over the course of a couple weeks. And so I had to design an entire course in a topic called linear algebra for Gillian's character to pass out tests, to have exams, to have stuff on the chalkboard, to be a part of this lecture. So it felt like a real university course. And one of the most surreal things I did for the movie, in addition to being in a scene with David Strathairn, which was beyond surreal, the second most surreal thing was Gillian Anderson wanting to be this math professor. At the time, the crew wasn't shooting her scenes yet. She was over in the UK, and she was prepping for her role, and she was studying her lines. And she asked Ryan Esslinger, the director, to ask me to make a video. And the video was her scenes being a math professor. So there are scenes that I helped the director write, or the writer write, of Gillian's character writing on the board, writing some equations on the board and explaining the equations, and then hilarity ensues as she interacts with her students. And what she wanted was like, I have no idea what this math means. This is nonsense to me, and I don't blame her, because it's linear algebra, but I need to pretend to know, like I know what I'm talking about. So she asked me to make a video doing her lines of writing on the board and saying her lines like, hey, you could blah, 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 blah. So she could pretend to be a math professor. And that was pretty cool. I had a default amount of respect for any actor or actress. And so I had a default amount of respect for Gillian Anderson. My respect for her as an actor went up a lot because she really wanted to commit. Like she wanted to make it convincing that she was a math professor. And so if in that scene, if she tends to come off as a little bit sarcastic, as a 30-something bald guy, that's just method acting, man. That's just her really sinking into the role. And unfortunately, this broadcast is almost done. Thank you for joining me on this voyage of space radio. By the way, UFO comes out September 4th. I don't remember if I've mentioned that or not, but there it is, September 4th on digital platforms. Once again, I'm Paul Sutter, and this show is brought to you by the Ohio State University Department of Astronomy. Learn more at astronomy at osu.edu. This show is also brought to you by you. Visit patreon.com/pmsutter to learn how you can contribute. Thanks to Greg Moebius for producing, Nancy Graziano for wrangling the space cadets, Dan Michalko for being awesome, and all the fine crew at WCBE Radio for making this show possible. We record every Thursday at 4 p.m. Eastern. Call 888-581-0708 or leave a voicemail to join me on the air. You can also catch the live streams on YouTube and Twitch. That's spaceradioshow.com. There's also podcasts, links to all the episodes, links to social media, all there on spaceradioshow.com. Thanks again, Earthlings, for listening. See you next week. And remember, science is for sharing. End of transmission. Yes, exactly. 0132. Gillian is just so intense, and she's going to get up there and be like, yeah, whatever. A equals B times X. A is a matrix. Guys, you should figure this out. Because that's how I would teach it. Or there's lots of hand gestures. Check it out, guys. If A is a matrix, it represents a two-dimensional... She'll get into it. I haven't seen the scene yet. I have access to a screener, but I want to watch it. I want to watch it on the big screen. Sony did send me the clip of my scene with David Strathairn. They sent me that clip. They cut it out, and then they said I could share it on social media. So follow me on social media at Paul Matt Sutter. I'll drop that clip on social media.
You have to rehearse?
Yes, I did. I had to audition the whole deal because I played a character. It was not, by the way, folks, I'm talking to Greg, not just some, it was not a cameo. It was not a cameo. I had a speaking role, and I had to audition for it. And I auditioned and was cleared by the casting director and the director. And I rehearsed, and then I had to sit in that scene, and we did the scene 1,000 times. And then we cut my line. Because it was just a joke. It was a moment of levity, and it's just in the flow of connecting one scene to another, it just didn't quite fit. The director said my performance was great. And there might be a director's cut with me in it.
The two galaxies. Yes.
Greg's guess, what he wants to name the merged Andromeda Milky Way is the cosmic crossroads. It took him 10 minutes to think of that. 10 minutes.
Lame.
SAHM and am I interested in astrophotography conference? Maybe. Send me the deets. I'd be interested. Yes, Nancy Graziano, you're the best. You could do a good job of keeping those space cadets in line. Yeah, Hal Tuberman, I will put the scene on social media, or you can watch the movie. I think it will be on Amazon. I can't say that officially because I don't think they've figured out the distribution channel yet. They're still in negotiation. I'm pretty sure it's going to be Amazon Prime. But don't quote me on that. Don't quote me. I know I just broadcast it on live and it's recorded, but don't quote me. Hey, Exoplanets channel. Unfortunately, we're just about to wrap up. But last things last, I need a name for this episode. Give me a title. We had some amazing questions. So we talked about Asteroid Bennu. We got to dig deeper into Asteroid Bennu, which, guys, that is my favorite thing. That's my favorite thing. When I do a news story and then you have questions based on the news story so I can flesh it out even more, I absolutely love that. I absolutely love it. I love all the questions equally, but I do also love when I get a chance to follow up on the news story and dig deeper. I am not going to call it Gillian Anderson a sarcastic bald guy. Oh, maybe I want to. SAHM, yeah, send me the details. Send me a note. You can access my email through YouTube contact info. Maybe we'll call it Cosmic Crossroads. Maybe we'll call the episode Cosmic Crossroads. Or Bennu Bennu. Bennu Bennu. I like that. Oh, Thunderduck is on iTunes pre-order right now. Good to know. I gotta make a note of that. This is me making a note. iTunes UFO pre-order. Good to know, so I can start sharing that link. Thank you. Maybe, yeah, Asteroid Bennu and the Cosmic Crossroad. I like that. That's a lovely title. Touching Space Carbon. Oh, Touching Asteroid Cream. I'm not going to call it Asteroid Cream. Come on, dude. I love it, though. I love it, but I can't call it that. We like Cosmic Crossroads. It might be, it'll either be just Cosmic Crossroads or be Asteroid Bennu and the Cosmic Crossroads. Sounds like a band. Ladies and gentlemen, introducing, opening for Rush, Asteroid Bennu and the Cosmic Crossroad. I can dig it. Thank you so much, everyone, and I will see you again next week. Thanks for a great show. You make this show possible. I really mean it.